So the question comes up as designers when we're working with an owner. We have to demonstrate that these projects are going to work and they're going to have longevity for the life cycle of the project. Currently, we're relying on one ASTM method, this D6766 method, to demonstrate the permeability or the performance of the product. And so what we're going to talk about from here to the end is a performance assessment of polymer-modified GCLs or bentonite polymer composites. And everything's going to hinge around this triaxial permeability test. When you're designing a testing program to evaluate the product, you really have to ask a lot of questions of your laboratories and who you're interacting with. I want to say that the testing programs they're certainly non-trivial. And when you engage the right people out in the engineering community, they can become much more easily performed, but you still have to ask these right questions. And so I'm going to go over some of these details with you so that you can develop that skill set. The nuances are everything from the testing equipment. Do we have a falling head constant tailwater cell, as in this picture here, or are we using a falling head rising tailwater? We find that there's problems with both pieces of equipment that we need to talk about with our laboratories and the impacts on the data streams that we get out of it. We need to talk about how we're going to analyze the leachate that we're using, right? Professor Benson mentioned earlier that in the last year, these leachate concentrations have gotten stronger and stronger by a log cycle. We're going to talk about how we pre-hydrate our samples. Are we going to hydrate with the leachate, or are we going to hydrate with water in the laboratory, or some in-between state? What stress level are we placing on our specimens? How do we decide when we're going to terminate the test? What is hydraulic equilibrium? What is chemical equilibrium? What's best? Where are some weaknesses within our test standard, and how to know it? But the underlying thing is this takes time. But it's a process, and if you follow the process, you can arrive at a state that demonstrates that this product will work for your owner. And remember, this is across multiple industries, with maybe the exception of MSW leachates. We're talking about brines, liquors, and leachate solutions. So in the beginning, we sit down with our clients as designers, and we're going to talk to them about their waste stream, and we want to walk off that site at the end of the day with a leachate sample and get it to the laboratory. Figure out what the chemical analysis is. And more than likely, I hear this a lot from different owners when I'm on the phone with them. Oh, leachate hasn't changed in 15 years. I'd bet that it has changed. Sites are implementing new processes all the time within these different industries. A couple weeks go by, we get our analytical data back, and then you're at a position to use the analytical data to make decisions about what products to test in the permeameter cells, and then the permeability testing starts. As we go through that process, it takes time, and we have to get out in front, because you use the current state to test for your future build state, and then it's a cycle. Continue testing, continue updating, because polymers change. There's no one magic polymer out there that solves every problem. They're all different products, and different products for different industries, and new things are being developed all the time. The geosynthetic world is a dynamic environment.